Thank you very much, and thank you for everybody for coming today. And I'm also very pleased to be at this university. It's the first time I'm here, and especially also I've learned more about what the FRAM Institute does, which I think is really important work and something that is of great use for us at the EU agencies, because we really need to have somebody who thinks about all this science. How can we actually use that in the policies, in the legislations, to prevent negative impacts of the use of chemicals, for instance. So I know the title says EU research and policies. I will not go very much into some of the policy, ongoing policy developments, but in the discussion afterwards we can maybe take that. But more give you kind of a thinking of like, why are we concerned about mixtures, which tools do we have right now, which tools could be developed, and then go a little bit into some of the EU research, big EU research projects like the Human Biomonitoring for Europe, which we have been very involved in at the European Environment Agency. And I don't know about questions, but you can...
It's up to you.
Yeah, if you have a burning question, you're welcome to ask along the way. Okay, so at the European Environment Agency, which is situated in Copenhagen, some might ask, what are we doing? The EEA is actually the oldest agency of all EU agencies from 1996. And what we do is we gather a lot of data and evidence on the state of the European environment, but we also assess it to understand which direction is it going, what are the impact of human activities, and then we use that knowledge also to feed into the policy processes. And a little part of our work is to frame also new issues, and we are the only agency in Europe which have that ability, so we can actually go across different policies, and that is where I'm situated. I'm in this cross-policy area. And once every 5 years, we publish the State and Outlook of the Environment report. This is actually the only thing we're supposed to do under the mandate. And we will have a new one coming up in 2020. And for the first time, there will be a chapter on chemicals for the first time in 20 years. And we also work very much with our countries, which consist of both European member states, but also of other countries outside the EU. So we have actually 39 countries we work with on the European continental plate. So first of all, I would say a little bit about like, why should we be concerned about chemicals, and what is the challenge we're facing? Well, first of all, I mean, chemicals is used everywhere, and there have been risks associated with their use. Everybody kind of know that. We have now a situation where we used to be the biggest producer in Europe, but now US and Europe are about the same, and China has really taken over. So this, of course, means that it's not just us using chemicals, but we have to think about the use and import of products, and how what we consume is also affecting what is being produced in China, emitted, and how this can also transfer, move around the world. And if you look at what it's used for, in Europe, you see it's really, this is the sales, so it's not the actual volume, but we don't have the volume data, so we have to use the sales data. So this is one of the proxies that we're working with. And you see petrochemicals is about a quarter, but consumer chemicals about 14%. Specialty chemicals is what we come across in a lot of our everyday products, like detergents and paints and inks and pesticides, dyes, etc. Basic inorganics is very much used in industry, but also as fertilizers. This is a large use actually, but it doesn't cost so much, so it looks a bit smaller. And then we have the polymers, the plastics issue, as you probably have heard of. And this means that the chemicals can come from many different sources. When it's produced somewhere, it can be emitted, but it can be emitted to the air, to the soil, to the water. Then we can have a wastewater treatment plant here that does something to and reduces the emissions to the environment, hopefully. We can have emissions from the households, from the fertilizer, the agriculture. from mobility, transport, from energy production, etc., from shipping, etc. So basically all these human activities has an impact on emissions of chemicals to the environment. But also in our everyday life, we are exposed to many different sources of chemicals from the products we're in contact with. This is food contact materials. As said, I worked with actually these ones, the coated paper and board, where you can use chemicals to prevent fat and water to be soaked into it, so it looks better. It doesn't give it much more of a performance, but it at least looks better and feels better. This is the fluorinated chemicals you can be concerned with here. You have, for instance, the coating inside the metal can be bisphenols, or an epoxy that emits bisphenols, which are endocrine disruptors, for instance. These ones can be immunotoxic, so decrease our ability to fight diseases over time, especially when you're exposed at an early age. And then we have cleaning agents, textiles, and etc., electronics, toys. And when we talk about mixtures, we then talk about two different types, or combined exposure to chemicals. We have aggregate exposure, which is where you have the same chemical, let's say the bisphenol, that can come from different sources. It can come from here, but it could also come from here. And so you then sum the same chemical from different sources, and then you talk about aggregate exposure. But you could also have combined exposure, or what we talk about chemical mixtures, which is really all the different chemicals coming from all the different sources. So you see, the minute you talk about mixtures, it starts to get a little bit more complicated. And it can come, we say it comes from multiple sources via multiple pathways. Yeah. And if you look at the world, where are we going? Are we just plateauing or what? But these are data from 2012, where you could see that the projected, this is 2010, 30, and 2050, and you see we expect in the world really to have an increasing dependency on chemicals, which means we use more, which means that unless we do something very differently, we will also have more emissions to the environment. And it has moved from OECD countries, which include Europe and the US, to actually, it will be an increasing production in the BRICS countries, such as China, which was also what I showed before. So what is to be concerned about that? Well, part of the reason is that if you have increased use, which is then a proxy for that you get exposed to more, let's just assume that you get exposed to the same amount as you do today every time you use a kilogram, then of chemicals, then if you use more, you will also have higher exposure. But that means that the risk will also increase. So we talk about the risk of chemicals as a combination of how toxic or hazardous it is, and how big is the exposure. So if you have this going up, you will also have the risk going up. Unless, of course, you bring the hazard down. But then if we look at the data from Eurostat on how hazardous the chemicals are, we can see that according to these CLP criteria, which is the it consists of 12 criteria of hazards. You see some of them here. That they say that 62% of the chemicals used are hazardous to human health, and about 35% are hazardous to ecosystems. And some of these overlap, but there are about 38% which have no registered hazards. It doesn't mean that they're not hazardous, because these criteria only include some of the toxicities. There are others that are not included, for instance, toxicity to terrestrial ecosystems or immunotoxicity are not included. So basically, this is the situation. So it looks as if in this situation that we have an increasing risk. And then, of course, the question is how much, that is for single chemicals, but how about the mixtures? On top of this, we also have this changing context where we know that that it's not just chemicals that affect our health, it's also noise, it's stress, it's increasing heat in certain countries, and other things like microbiological issues and pests. And it's very difficult to foresee future uses, and because the context is changing. We used to go from a situation where we produced something, we used it, and then we disposed of it, the so-called linear economy. But now we are in a situation where we have resource scarcity because we are using things up very fast, and that means that we have to start to recycle things. So we are going into a circular economy where we have to reuse the sludge for fertilizer, we have to reuse the plastic and the metals, and that changed the way we use the products. We also have to reuse the plastics. So before we could foresee, when we put something on the market, we could foresee that this was a toy which was supposed to be used under certain circumstances. And then we can have an exposure scenario where we can then assess the risk of exposure. But in the future, and even now, you can say also for the food contact materials, you might have a food contact material which is made out of old newspapers. And when those newspapers were made, you did not consider the printing ink to be used in contact with food. So it was not assessed for food contact. But it is actually getting in contact with food if you use the recycled materials. And this is just one of many situations which we will see more in the future. So everything we use for one context might be used in a different context. And therefore it's difficult to foresee the future exposure scenarios. And then of course we have the globalization. We have increased population, putting more pressure on our resources, which means that we might have to use lesser quality of resources, for instance, of fertilizers. And we have climate change. And what I showed here is a recent example of the storm Katrina in the US, Florence, which has flooded some Superfund sites. And the Superfund sites are the hazardous chemicals that were put in the ground, landfilled there, and thought to be safe. But now it's flooded, and that means you remobilize the contaminants. So this is another situation we have to consider. And meanwhile, we have the Sustainable Development Goals. We would like to, provide a good life for everybody in a sustainable way. And with regards to responsible production and consumption, we should, by 2020, that is in a year, we should achieve the environmentally sound management of chemicals and all wastes throughout the whole life cycle, from production, use, and recycling, etc. And we should significantly reduce releases of chemicals to air, water, and soil to minimize the impact on human health and the environment. So these are really ambitious goals. And I come from a conference about a month ago where we heard from UNEP that we're actually doing well on a lot of these sustainable development goals, especially in providing education and food and health, etc. But and shelter, but a lot of these things have come at the cost of environmental degradation. So while we are improving in some areas, we are actually degrading the foundation of our societies, which are the ecosystems. So we need to think about how to address this. How can we produce something here in a good way, in a safe way? And how can we assess the risks, not just of one chemical, but of several chemicals? And so what we also see, and that is from the Solutions Project, which was a big Horizon 2020 project that just ended here in September, I think, is that if we look at just the single chemicals and how they affect the risk of these single chemicals of being emitted into river waters of Europe, we can see that for acute toxicity, just for one single chemical, we can see that there are, the more red it gets, the higher the chemical risk is. And this is the risk if the concentration goes above the effect level. And we can see that we have quite a bit of countries affected here. It looks kind of okay. There are some gray areas, that is where when you have less than 6 sites. But if you take the mean concentration and look at the chronic risk, so over a long time, you see, and for many different organisms, you see a different picture where actually several countries are having levels of contaminants in the river water where you can expect it to affect the biodiversity. And I know there's an article coming out soon which actually compares the mixtures of the chemicals with the effects of biodiversity, where it's also showing that the mixtures of these chemicals are likely to have an impact of reduction about 20% of the biodiversity in rivers due to emission of chemicals. So that is in the environment and aquatic life. But also if you look at humans, what you see here is in breast milk. And then you can take, different chemicals, brominated flame retardants, for instance, here. And if it gets above 1 here, then there's a risk of you experiencing a negative effect. Can I actually point with this? Yes, that's better. And so this is the magical number. And if you look at the single substances, you see that many of them are below 1 here. But when you start to group them, here you have a group of substances, the phthalates, which are softeners used in toys, PVC for instance, also in food contact materials. Then this one starts to get at 1. And then you can continue with the other substances. Some are more worse than others. You have, for instance, here DDT, which is not really used anymore, but it's a very persistent substance that accumulates in humans and in biota. You can see here it is above, and also HCBs, which are some chlorinated compounds, byproducts of PCBs. They are starting to get high in the group of pesticides, and then the group of PCB, polychlorinated biphenyls, all the way up at 55. And if you sum everything, then you're up at 66. So this means it's 66 times above the safe level. And this is in breast milk. So if children being fed by this will experience quite a bit of exposure to chemicals. So there is definitely something to be concerned about. And this is actually a slide I've borrowed from Christina Rodin, who in ISPRA last year showed some of the different regulations where that cover all these different policies. All these different products are covered by many different policies. And the issue is then, of course, how can we then make sure that these different policies take into account aggregated exposure from different mixtures, different chemicals for all these different sources. And that is a bit of a challenge. But mixtures is not something new. It is, we might talk more about it, but it's something that has been considered for a long time in the EU. So back in 1991, there was this report from the Commission where it says the scientific basis for the assessment of toxic potential of several chemical substances in combination at a low level. So in a way, this is where we are still. But it was considered there. Then we had the white paper in 2001, which was leading also into forming the basis of REACH. And then again in 2009, we have something about combination effects of chemicals. And this also was reiterated in the 7th Environmental Action Program, where we say we should address chemicals. And there was also a communication saying that by 2015, we should have some kind of strategy for mixtures. We are not there yet, but at least we are trying now. We have gathered a lot of evidence from different research projects, so maybe we are about ready to do something about it, to actually address it in a coherent way across all the policies here. Because I should also say that you might have heard of the refit process. The refit process is the EU Commission that has looked across chemicals legislation and looked whether it's coherent, effective, and has and efficient and has added value. And what they have come, one of the conclusions is that it is not coherent. So not surprisingly, because we deal with the same chemical in all these different products and we kind of ignore what is in the other area, it is not coherent across the policies. And mixtures is not very often dealt with in these policies. So the way that we normally deal with chemicals to assess their risk is to do a risk assessment. And as I said before, risk is a combination of hazard and exposure. And I should say that it's, of course, the hazard is not just one hazard. It can be several hazards. And even if it's, let's say, the hazard of endocrine disruption, then it depends also at the time you're exposed. So there are there's much more to this than just hazard and exposure. There are also different exposure routes, and there's how you can uptake. The chemical will also affect how much you in the end experience as a risk. But the way we normally deal with it is we take the hazard of a single chemical, sometimes of mixtures, and then we look at the exposure from either a single source or several sources. And what I've shown here is that typically the hazard approach is something which is used upstream in a kind of a pre-policy or pre-market context. At the production level, for instance, REACH, where you get information about the hazards, and then based on that you can say it's fine, or if there's special concerns, then let's say it's a persistent bioaccumulative toxic or very persistent, very bioaccumulative compound, then it goes through a different process and then it's assessed whether it can go on the market or not. But then for a lot of the thematic legislation, and this is what we call a horizontal legislation, because at the production time it affects the chemical which can be used for many different end purposes. But when we look at it from the exposure side, often a lot of the downstream legislation, so by downstream I mean these specific legislations like toys, RoHS, etc. So toys and electronic equipment and medicinal devices, etc. Those are downstream legislations because they regulate the use of the product in a way to minimize the exposure of the chemical. Sometimes they also have hazard in, but very often it would be regulated on the exposure side. So yeah. And then the issue is that typically we only do this for single substances and in single media in the so-called policy silos. So these different regulations are what we call policy silos. And it requires a lot of input of the hazard and exposure because it's hazards for different toxicological endpoints. Just think of humans, how many ways we can get sick, and then add all different kinds of animals, how they can also get sick from something. And then in different media. So it's especially if you take the environment, there are many, many different media that the chemicals can be in. On top of that, we have the issue of when we have some data, how good is the quality? It might be a golden standard, probably here at Gothenburg University, you've produced kind of really, really good science, thoroughly validated, whatever. But if you're a small company and you might not have as much money, you might say, what is the minimum standard to get it to pass through? And you just, maybe you choose the cheapest, maybe it's less validated. So the information that the authorities have to base their assessments on can be of very, very varied quality. And recently, UBA, which is the German Environmental Protection Agency, they went through the dossiers of REACH, selected a subset of cases, registrations, and they only found out of about 1,800, they only found one which had a sufficiently high quality. And the rest, 75% of it was kind of bad quality. And then you had about the 25% rest, which was inconclusive evidence. So if when you go the risk assessment route, it is not straightforward. And then on top of that, when you want then to combine it in different ways with different for different chemicals, you just add complexity to it. And this is really the basis of our assessment, but that basis, our scientific assessment. And then that basis then also being used to be fed into the socioeconomic assessment. So sometimes you say, well, we can see there are some issues with these chemicals. They might be a risk, but we find they are of societal relevance, so we still want to use it. So if it really has a high benefit for the society, it might be a pesticide, it might be a pharmaceutical, then we are willing to accept that risk. But you can only assess something based on the evidence you have. So also it also affects the next level of economic assessment. And then another issue is that that in terms of the exposure, oh, there's a mistake there. Then if you are in a situation, let's say pre-policy, in the reach stage before it gets onto the market and you want to assess the exposure, how do you get the data? Because it's not supposed to be on the market, so you're not supposed to be exposed to it. Then it's difficult to get epidemiological studies, so let's say human exposure data. Still, it is very often expected that we can get that type of data. So if you don't have that type of data, you're not supposed to have it because it's not in line with REACH. No, first you have the data, then the market. And then you will have to use other methods, and then you would have to use estimates, and you would have to think about what is the tonnage of something that is used. But that tonnage is still difficult to get hold of because it's not publicly available because of protection of properties of the what is it called, the CPI? Anyhow, it's to protect the companies so their trade secrets are not shared. But it means that it can be very, very difficult to get this information, and therefore also to assess both the risk and the cost. So ECHA, and this is a slide I have borrowed from a presentation 2 years ago by Jack Brin from ECHA, who presented in a conference in Denmark called Towards a Non-Toxic Future. And he actually said, well, how should we deal with combination effects? He says, the science is sufficiently clear for decades. There are combination effects. We also actually have, thanks to people like Thomas Backhaus and others, we have information about how we can add the toxicities together, like the dose addition and others. I will not go into that, but we have some good idea of how we can do it. And that is also called concentration addition. But the thing is that if you want to combine every possible combination of every possible chemical in every possible media and every possible concentrations, it's simply too big a task. I just showed you a lot of the issues with the risk assessment. And then if you have to do that for everything, it is a never-ending story. And even if you could do it, and you probably could, it would cost you a lot of money. So would societies like to spend the money on that? Would you, as a consumer, have to pay the price of a much more expensive product? So his suggestion was then to actually reduce the probability that the effects of these combined exposure to mixtures of chemicals happen. So what he says is that right now you have an assessment where you say, if this has an index I showed before, that if you have an exposure which is lower than the level, so a concentration which is lower than the concentration where you happen an effect, if that is lower than 1, it's fine. But this is only for one chemical and in one media. So what he suggests is that you actually put in some safety factors, pragmatic safety factors. And so he suggested divide it by 10 or 100, which would mean that you reduce this to 0 or 0.1. And what this means is that you increase the margin of safety. And this is kind of a wild guess, because you don't have, you have, should you use 10, 100, 200, or 7.5? And that's a good, that's the question. And this is where we really need somebody to produce some case studies and evidence to show what could be a good factor. But there are also other alternatives. For instance, first of all, I think it's also relevant to mention that Bjørn Hansen, at a meeting we had in the EEA last year, he was not the director of ECHA at the time, but now he is. He said that we should look at the world from a chemicals perspective. Instead of looking at it from a media perspective, is it used in toys or is it used in clothing, or we should use which chemical is used for which purposes. So we should take that approach. And then he didn't say the rest, but what I'm then mentioning here is maybe we should consider these pragmatic factors. This margin of safety is one, but there could be other factors. One is the mixture assessment factor, the MAF. There could be other. There could be factors for very persistent compounds that accumulate in people, etc. But it would be good to think about which pragmatic factors could be used, what should the level be, what should the size be of it, and to have the scientific evidence to demonstrate why it should be at that level. It might also be that it could be for different people or different subgroups, it could be at different levels. And then worth considering is also that patterns change over time. What we think was safe today might be discovered to be unsafe tomorrow or in 10 years. And these are examples of two reports, if you have of books. Actually, this book is this thick, which is called Late Lessons from Early Warnings. And it contains about 88 studies, I think, on chemicals, and looks at the evidence we had at an early stage and what did we know at the beginning, and then looking like 10, 20, 50, 30, 70, 100 years ahead, and then see what kind of evidence do we have now. And what was found here is that harm expands over time, because we typically learn that, at first we discovered lead was kind of problematic, neurotoxic, but then we also discovered that it has all sorts of other toxicities later on. And so it's difficult to actually foresee not just the exposure, but also the toxicities. And for that reason, we might want to think not just to have a risk assessment upfront and say now we do the best with our current knowledge to prevent too high risk, but also to have surveillance systems where we do a checkpoint once in a while to check if we have done it right, and that could be by monitoring many more chemicals than we are doing right now, for instance, those listed in ECHA, but also looking in fast responding media, environmental media, that could be air and water, or even in animals. Humans are not fast responding media. We typically take about 30 years before we have accumulated something that is emitted to the environment. But then maybe prioritize to look for the most potent compounds and accumulated chemicals. Find ways to look for the health of ecosystems and health of people to see are there any unknown effects. And an example here is the bees, as you have heard that the pollinators such as bees and insects are really declining fast in Europe, and possibly likely due to nicotinoids, pesticides, because they had some effects that were not known at the time and therefore not assessed. And it was discovered because the beekeepers said that we have a problem, they are dying, the bees. And so also think about what are good indicators, and then think about, are our methods comprehensive enough? Do we take in enough and analyze enough substances? And looking at the time, I will go a little bit faster over how much, maybe, fine, okay. So we can also look at policies to which policy tools can be developed to deal with data when it's limited. Basically, it's about taking the precautionary principle, which was really the outcome of these late lessons from early warnings, which said you have to act earlier on the evidence. But it didn't say how we could act on it. And that is really needed. How can we act on limited evidence? Because we cannot just take something and say, we stop using anything. We have to say, be a little bit more precise and say, at this level of evidence, we can use it for this, and we can take that actions and put this on the market, or give some restrictions on what can be used. And then also maybe become better across the policies to combine different strands of evidence. It is so that in certain policies you're used to only use in vivo studies, animal studies, and in others you are only using in silico, such as QSAR, quantitative structure activity relationship, and in combination with, let's say, in vivo and in vitro, which is cell-based, but you're not using epidemiological studies. But if we combine all the different strands of evidence, then we are at a better situation of getting a fuller picture, and therefore maybe also detecting some of the issues earlier. And then the issue here about getting the exposure data, well, maybe we can start with actually getting more specific tonnages of what is being used for which purpose. The information is there, but it is not publicly available. That is something that would be very nice to have. ECHA might be a good place to start there. And then also we are building these information platform for chemical monitoring in Europe, which is called IPChem. And basically what it does, it has 4 modules here: environment, products and indoor air, food and feed, and human biomonitoring. And what we're doing is that we're collecting the occurrence levels of different concentrations of chemicals in different media. And the aim is that we should be able to use that to assess the mixtures. That is a challenge, and that requires a lot of harmonized methods. So now I'll just switch and talk a little bit about EU research activities. So if you want to know about research activities on mixtures, I can recommend this, this article here, because it was made from, with contribution from many of the big EU projects under Horizon 2020, which assesses different types of toxicities, toxicity methods to assess toxicity, how to combine, how can you combine toxicity to get a proper estimate of the total impact in different media, humans, etc. And it goes through, what are the different research activities, but also provides some suggestions for the way forward. And I would just mention then a little bit more about this human biomonitoring for Europe, because as I said, one of the pillars in the information for information IPChem is human biomonitoring. And this is important because if you look at the different media like air or water, you can see that you have chemicals there, but it is still difficult to know whether it ends up in our bodies. Is it actually affecting us? You might drink it, but it runs through, and then it's maybe not a problem. But if you go into humans and you measure what are the chemicals in the blood, then you can see, okay, these really matter. So it helps to prioritize. And you can maybe also see what are the impacts on it if you combine it with health data. So it is not a fast responding mechanism, but it can give us a guidance to where are we? What are the impacts? What are the costs as well? And what are the most important sources that we should reduce? And it's a huge project. It has 121 partners across Europe, really big budget. And in relation to mixtures, there's the developing of human biomonitoring indicators, but also a whole work package on mixtures. And I should say we also have a work package on emerging contaminants, which looks at new substances, which of course also is relevant for mixtures. And we have developed there's another publication here which is describes a methodology for how we can develop human biomonitoring indicators. And very briefly, it goes through how to select these indicators according to different principles. There's something about the policy relevance at EU level, national level, but also the societal relevance. And then in this project, we started with identifying 9 different groups of substances. Now we have 9 additional, which were considered, the first 9 were because they were considered of concern, but also because we had data for them. And the next 9, they are more of chemicals that are of societal concern right now or national concern. Available data, etc. And we chose then bisphenol A and the group of the per and polyfluorinated substances because they ticked a lot of boxes. One was short-lived and one was accumulative. So different situation with the data there. And together with a lot of institutions, we ended up choosing a methodology which was inspired by the Norman water indicators, which is also the hazard index here, where we looked at calculating the exceedance of a substance, exceedance of a health-based guidance value. So it's again the hazard index. Are we above 1 or below 1? And here we used the different distributions. You can take the average, but you can also take the P95, which would say you would take most of the distribution, so you would also include the vulnerable groups, not all of them. If you take 100, you basically take the most risky, the one with the highest exposure, and this is, you take most of them. But there are different traditions of which percentile you use, and it will give you a different kind of margin of safety. And basically this was then suggested to be used for single substances, and these health-based guidance value we had input from another work package that developed that. But also for the mixtures, then we suggested to do this with, you sum the different substances belonging to the same group, and then, but you could actually also say that you could in principle do this for different compounds, even if they have different toxicological endpoints, but we decided it's too early for that, but we wanted to stay more on the safe side. So we started with the substances that have the same endpoints and for which we do have health-based guidance values. But the problem is that some of them did not have health-based guidance values. So for instance, the substances PFH excess is a substance which has been classified as a very persistent, very bioaccumulative compound, but we don't have toxicity data for it, so we cannot make a health-based guidance value. So even though that it's a relevant substance, we couldn't include it. We then discussed, should we use read across, but there was a sense that probably not yet, but you can in principle do it. But then instead we proposed to make this exposure indicator, which is a different type of indicator because it just sums the concentrations of all the chemicals. This is not for risk assessment. This is more for surveillance. It is more saying, are there certain areas of Europe where you have high exposure to chemicals? It could also be, are there certain subpopulations that have high exposure to chemicals? And so it just gives you kind of picture in time of like, what is the exposure? The issue is, of course, the more chemicals you measure, the higher it gets. So that is something you have to deal with. Whereas this one is something you can actually use to take action on because it is a risk-based approach. So authorities might be more happy to use this one, but only use this for guidance. And this is just an example of 2 of them. Here you see where they have the single substances. You can see the P50 and the P95, so the average and the total. And then compared to the health-based guidance value. And for children and women, you see that women are just below, children are a bit above for this compound called PFOA, perfluorooctanoic acid, whereas for the PFOS, it's above. But if you take the sum of all the chemicals, you see that it is actually going down. And it is going down, this is Swedish data, by the way. It's actually going down because one of the most problematic substances, PFOS, this one, was stopped being used for a while, and now it's going down. So this is kind of an example of how you can use it. And in the work package 15, it has these objectives. It wants to develop the indicators. I should say these other indicators were from a different work package, but they are also developing more specific mixture indicators, which are more precise. And also trying to find out what is the drivers of the mixture toxicity. So what is the most important or most potent compound? And then they want to look at the different HBM mixture data, and they want to know what are the real-life patterns to mixtures. I mentioned before that it's good to get some case studies to see what is the typical pattern, what is the typical level, to inform which mixture assessment factors we could have. So this is what this can inform. And then it's developing new approaches and practical approaches to also assess the potential health risk, because they compare it with health. And finally, taking all this information and trying to advise policymakers of how they can deal with mixtures. And they have these 3 different definitions of mixtures, by the way. Intentional, which is a mixture you're selling where it's pre-mixed. Unintentional, where you have maybe a substance and then you have some impurities. And coincidental mixtures, where you have emissions of chemicals into a media where there's already chemicals, so into a waterway, and then you have some background chemicals. And then, they are taking, this is more for interest. Like, if you're interested, you can ask later about what exactly they're doing, but it's rather specific, taking a lot of the state-of-the-art methods and extending them. And they're also trying to look at some data mining procedures where they're looking into how different chemicals, this is not from this study here, but another study, Helix study, and sorry that it's a little bit blurred, but where they try to look at, when you look at all these different chemicals, which chemicals are typically present in combination with others. So these ones are very often in combination with each other. And you can see here also, though there are different groups, they are often present in combination with each other. And that helps to identify possible sources and then go upstream and do something of the sources. And you can see they look into these determinators like sampling period, socioeconomic status. That could be, are you a worker? Are you living in a poor area? Are you eating a lot of, do you have a high, gender, weight, and age. So, how can we then move forward? Well, of course, or options to move forward. Of course, we can do all these assessments, but eventually, it should hopefully lead to reducing the amount of chemicals or the amount of hazardous chemicals that can impact the environment or health. And one of the ways that are under consideration, and ECHA has a strategy now for innovation in safer chemicals, is to think about the chemicals at the design stage. Instead of just taking something down from the shelf and using it and then afterwards finding out it's problematic, think about it from the beginning, test it with the existing knowledge, and then try to make chemicals that are safer by design, and also products. And that you could that would also allow us to avoid using the most problematic chemicals, because you would not choose a substance of very high concern if you do this safe by design. And by the way, we are right now, today there's a kickoff meeting to discuss a big EU Horizon Europe project on this one. We don't know if it's going through, but there might be a project on this. Also, maybe look at to reduce the complexity, because the more chemicals you have, the higher the number of possible combinations, and that makes everything more difficult. And the more substances you have to take through a hazard assessment, and the more substances you have to analyze to get the exposure. Then we have the non-toxic environment strategy, which unfortunately has been put on hold. It was foreseen for this year. There's a whole development of 7 different sub-themes of what could be done. Mixtures is one of them. But it is just on hold until the next commission gets in place. So let's see what happens. And the advantage of this is that this is the time of opportunity to develop the knowledge that can inform the non-toxic environment strategy. And I know that, again, FRAM and Thomas and others are working on this, which is great. Then also maybe think about financial incentives. I mean, could you make it more expensive to use hazardous substances and to use a lot of uncharacterized chemicals? Then maybe that could be an incentive to reduce this complexity and also to take away the worst ones. But also that could go via insurance cost, extended producer responsibility. So a company that puts something in the market, they have a responsibility if somebody gets sick down the line. But also other business models, priority access to markets, extension of patents, etc. And finally, I want to mention that this is, of course, a lot of push, stick, but there's also the carrot, which is the procurement. And there we have, for instance, public procurement, which is what the governments and cities buy. So if they say we are trying to buy safer products and chemicals, then that creates a pull, a market for developing that. And there's a big project called the Non-Haz Cities, which is the EU-funded project as well around the Baltic Sea. And I think Stockholm is part of it. I don't know if Göteborg is. I don't think so. But they have also looked at upstream, what are the consumers using, and trying to affect, their behavior to avoid chemicals from being emitted into the wastewater. And finally, private procurement, which is the companies that are responsible companies. And there we have they try to avoid using certain groups of substances, which could be the 6 classes, the dirty dozen. This is in the US a lot. Dirty dozen is co-op here in the Nordic area, zero discharge hazardous chemicals, and others. And actually working with these companies and defining which are a good grouping of chemicals can be highly effective. And this is the safe by design. Try to reduce, avoid using some of the most problematic halogenated and chemicals and heavy metals. Use more from what nature is using, and use data mining and modeling, etc. Alternative assessments. We have a lot of the tools already. So in conclusion, people and the environment are impacted by mixtures. We need to address these mixtures in a coherent way if we want to succeed. We need tools for that, and we need to think about if we can develop tools, or you can develop tools, that can assist the policymakers and the authorities also to take action even when there's limited evidence. So we don't have to wait 70 years when everything is polluted and we cannot remediate it anymore, or it's very difficult, but try to think about tools that can be used upfront, and then as part of that, design the chemicals in a safer way. And with that, I want to thank you and open for questions.